This lesson is talking about types of supports. An object can be supported in various ways to prevent moment. If you remember from week 2, moment is a certain amount of twist or torque. Support reactions, also known as boundary conditions, often act at the boundary or edges of an object and are described and distinguished by specialized symbols. The next 2 slides will dive deeper in depth. This chart will help categorize the different types of supports relating to the symbol, degrees of constraint, analogy, name, and whether it does or does not carry. Just to specify, does carry means it cannot go in that directional force, whereas does not carry means it has the potential to move in that directional force, as well as the degrees of constraints relate to the number of does carry forces. Before we begin, let's draw a reference coordinate system as well as state that Fx is the x direction, Fy is the y direction, and Mz is the moment about the z-axis. The first support is a simple support, which is also known as a pin support. This is the symbol. An example of this support is a rollerblade that is tied down. It carries Fx and Fy as the ropes holding down the rollerblade prevent it from moving horizontally and vertically. That means it has 2 degrees of constraint, as well as it does not carry Mz, as the skate ankle can flex, creating a moment. The second support is a roller support. This is the symbol. An example of this support is a rollerblade on the ground. It carries Fy as a normal rollerblade cannot move vertically. That means it has 1 degree of constraint. It does not carry Fx and Mz, as the rollerblade can move horizontally and the skate ankle can flex, creating a moment. This support is still a roller support, but placed vertically. This is the symbol. An example of this support is a normal rollerblade rotated 90 degrees counterclockwise. It carries Fx as a normal rollerblade turned 90 degrees counterclockwise, cannot move horizontally. That means it has 1 degree of constraint. It does not carry Fy and Mz, as the rollerblade can move vertically and the skate ankle can flex, creating a moment. This support is also a roller support, but placed at an angle. This is the symbol. An example of this support is a normal rollerblade on an angle. Since our coordinate system does not match with this specific example, we would have to create our own coordinate system. Let's create a coordinate system of r and s. Therefore, it carries Fs as a rollerblade cannot move perpendicular in the s direction. That means it has 1 degree of constraint. It does not carry Fr and Mz, as the rollerblade can move parallel in the r direction and the skate ankle can flex, creating a moment. The third type of support is a fixed support. This is the symbol. An example of this support is a metal post connected to the ground. It carries Fx, Fy, and Mz, as the post cannot move horizontally, vertically, or rotate to create a moment, respectively. That means it has 3 degrees of constraint. It does not carry any directional forces. The fourth type of support is a fixed roller support. This is the symbol. An example of this support is a pushcart or shopping cart. It carries Fy and Mz, as the cart cannot move vertically and cannot rotate, creating a moment. That means it has 2 degrees of constraint. It does not carry Fx, as the cart can move in the x direction. The last type of support is a free end. There is no symbol for this type of support. An example of this support is an arm. It carries nothing, which means it has 0 degrees of constraint. It does not carry Fx, Fy, and Mz, as an arm can move horizontally, vertically, and rotate to create a moment, respectively. Let's look at an example of an angled support. How would you show a support that moves freely along a plane inclined at 30 degrees counterclockwise from the horizontal, but cannot rotate? Feel free to pause the video and try it on your own if you would like. First, start by drawing a line angled at 30 degrees. Second, let's create our coordinate system. Third, draw a support that will allow you to move horizontally along the r-axis without creating a moment. This would be a fixed roller support.